Today's section is 2.6 Families of Transformations. Our objectives: describe transformations given the symbolic representation or the equation, graph the transformations given a parent function, apply transformations to determine new ordered pairs, and we're not going to do number 4, but number 4 would have been determine if a function is odd, even, or neither. So our key vocabulary to begin with. Parent function is the simplest form in the set of functions that form a family. So for example, we've learned linear functions, y equals x. We've learned absolute value functions, y equals the absolute value of x. We have just begun quadratic functions, so y equals x squared. These are all different types that we're going to be covering. Okay, so a transformation, there are different values: an a value, a c value, an h, and a k. So the first one that we're going to talk about is a translation. So a translation is a vertical or horizontal shift in the graph of a parent function without changing shape or orientation. So it's when you move up, down, left, and right. You're not spinning, you're not reflecting, things like that. Okay. A dilation is when you multiply the x and or the y value so that the parent function does change its shape. A stretch is a dilation that multiplies by a factor that's greater than 1. And so for this, if your absolute value of a is greater than 1, or your absolute value of c is greater than 1 as well. Okay. Your compression is when it's between 0 and 1. So if your factor is between 0 and 1, it's going to be a compression. And then a reflection. So a reflection flips the graph of a function across a line such as the x or y axis. So what's going to happen here is this. These are the different ones that you'll be familiar with. So the value is the number in front that multiplies. This controls your vertical. Okay. And so what happens is this: if the absolute value of a is greater than 1, it will be a vertical stretch. If the absolute value of a is between 0 and 1, that would be my vertical compression. Okay. If a is less than 0, it also indicates that there will be a reflection over the x-axis. Okay, so that's what the a value can control. The c value you're not going to see too often, okay, but the c value controls the horizontal dilation. Okay, now see here where it says your x's are going to lie to you? Whatever your c value is, that's not your dilation factor. You actually have to take, so we'll put it here, take reciprocal of c to determine the dilation factor. So what that means is this: if the reciprocal of c is greater than 1, it's going to be a horizontal stretch. If the reciprocal of c is between 0 and 1, it's a horizontal compression. Okay, and then if c value is less than 0, we are going to reflect over the y-axis. Okay, your h value is your horizontal shift. Okay, and so this one we talked about. This is where your x's are going to lie to you. So what that means is this: if you have x plus h, okay, so whatever it may be. So if this is x plus 3, that means your h value is negative 3, and that means that you're going to go left 3 units. Okay, if it is x minus 3, that actually means that your h value is 3, positive 3, and you're going to go right 3 units. Okay, and again, that's because it's supposed to follow the form x minus negative h. So if it's x minus negative 3, that's why it shows up as x plus 3. Okay, your k value is your vertical shift. So your vertical shift is standard as it is. If it's plus k, it's going to go up k units. And if it's minus k, it's going to go down k units. Okay, so up and down is pretty standard. Vertical dilation is anything multiplying in the front. Okay, so let's turn the page and let's practice. So I'll try a couple with you guys. Okay, so examples, f of x is my parent function. Describe the transformations that occur with g of x. So this first one, notice that it's 4 times my function. So what that tells me is that my a value is 4. So in this case, this would be a vertical dilation by a factor of, okay, I don't need this, but what I do know is that it will be a vertical stretch. Okay. Notice on this one, 4 is on the inside. So the difference there is that my C value is now 4. Now we're talking about horizontal. Anything inside the parentheses is horizontal. So this is a horizontal dilation by a factor of, now again, your x's are going to lie to you. You see 4, however, you have to treat it like a reciprocal, 1 over c. So this would actually be a horizontal compress. Okay, again, this one, your x's are lying to you. So this is just going to be right 9 units. Okay, inside the parentheses, it's another h value. This is negative 11, so this is going to be left 11 units. Okay, again, 2/3 is multiplying outside of the parentheses. That's an a value. So this is a vertical dilation by a factor of 2/3. Okay, because 2/3 is between 0 and 1, this would be a vertical stretch. Okay, notice the 2/3 inside. When it's inside the parentheses, that means my C value. So this is going to be a horizontal dilation by a factor of, again, you have to take the reciprocal. It is now 3 over 2. This is going to be a horizontal stretch. The reason why it's a stretch is because 3 over 2 is 1.5. It's larger than 1. Okay, this next one, the 17 plus 17 is outside of the parentheses. So that means that this is a k value. This means we're going to go up 17 units. So again, just to kind of point it out to you, a values are multiplying outside of the parentheses. Okay. C values are multiplying inside the parentheses. Your H values are being added and subtracted inside the parentheses, whereas your K values are being added and subtracted outside of the parentheses. Okay, so in this case, K would be negative 23, so we're going to go down 23 units. Okay, a negative in the front, that means my A value is negative 1. This is a reflection over my x-axis. Negative inside the parentheses, that's my C value. That is a reflection over the y-axis. What I like to think about is this. X comes before y in the alphabet. So if the negative is in the front, that's first, that's the x. If it shows up inside, it shows up second, that's the y. X comes before y, so x-axis and y-axis. Okay, so what we're going to do is we're going to pause here, and I want you to try to identify the multiple transformations that are happening within these functions. Okay, I'll give you a hint for this third one. You need to factor out the 3 first before you determine your transformations. Okay, so pause here. Oh, and the same thing with the fourth one, by the way. When you do the fourth one, factor out the negative 1 first. Okay, so pause here. Give these 5 problems a try. Let's see how we do. Okay, let's check out our answers. So for this first one, pretty straightforward. What I know is this. I know the A value is 3. I know the H value is negative 1. and I know that my k value is negative 2. Okay, so again, I'll just write it over here up top. So a f of c x minus h plus k. Okay, so a couple things. I have a vertical dilation by a factor of 3. I am going to go right 1 unit, and I'm going to go down 2 units. Okay. Second one, I know my a value is negative 1/6. There's two things going on for that. I have h is equal to 8 and k is equal to 1. Okay, so there are two things and then two more things. Because a is negative, that is my reflection. So that is a reflection over the x-axis. Because the a value, the absolute value of a is 1/6, this is my vertical dilation by a factor of 1/6. H is 8, so I am going to go, because it's positive, it's right 8 units. And k is positive, so I'm going to go up 1 unit as well. Okay, this third one's a little trickier. And I gave you a hint. I said factor out the 3 to begin with. So if you factor out a 3 to begin with, you see that it's x minus 3, like that. So what that tells me is the c value is 3, the h value is 3, and the k value is 4. So I have a horizontal dilation by a factor of 1/3, because again, you have to take the reciprocal. You're going to go right 3 units, and then you're going to go up 4 units. Okay. For this next one, the negative 2 is still there to begin with, so a is negative 2. That means that there's going to be 2 transformations for a negative a value. When I factor out the negative 1, that leaves me with x minus 1. That means my c value is negative 1. That's one transformation. And then my h value is also 1. That's my next transformation. So with h being 1, that just tells me go right 1 unit. Because my c value is negative, that's a reflection. So that's a reflection over the y-axis. Okay, a negative a value means to reflect over the x-axis. And the absolute value of a is 2, so my vertical dilation by a factor of 2. Okay. Remember, the negative is used up for the reflection, so all you're left with is just the numeric value, 2. This last one, my a value is negative 1, my c value is 5, my k value is negative 9. So negative a value reflect over x-axis, c value is 5, horizontal dilation by factor of 1/5, the reciprocal, and then k is negative 9, so I'm going to go down 9 units. Okay, so let's see how you did here. Out of 5, just so I know, put a plus, whatever. How many did you get correct on your own? It does not affect your score, just out of curiosity. How many did you get correct? Graphic representation. Okay, so I'm going to try one and let you guys try. So this is the graph of f of x at the moment. So it's this little, almost looks like a little mountain. Okay, there's 3 important points for me here. I'm looking at negative 2, negative 1. I am looking at 2, 3. And then I am also looking at 4, 1. Okay, so I'm going to use those as marker points here. So the first thing I want to do is I want to do a vertical dilation. Dilation by factor of 2. So what that means is vertical dilation means you are doubling all the y values. It's a 2y. So what that means is 3 times 2 is 6. 1 times 2 is 2. Negative 1 times 2 is negative 2. 0 times 2 is still 0. So what's going to happen is it's going to look like this. Oh, sorry, not 0 times 2. 1 times 2 would be here. The 0 that should still be there is the x-intercept because the y value is 0. So this is 2f of x. All I did was I doubled it. I gave it a vertical dilation. The next thing I'm going to do is I'm going to go left 3 units because my h value is negative 3. So from there, I just count 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so from here, I will just connect them. And there's my graph. Okay, so that's all we're doing. So try the next two. Okay, you got your graph, you got a reflection and a shift, and then for this last one, you got a reflection and a dilation. Okay, so give it a try. Let's see how we do. Pause here, and then we will try to see how we did. Okay, let's try these graph problems out. So again, I have my same points. I'm at negative 2, negative 1. I am at 2, 3, and I am at 4, 1. So the first transformation is where my a value is negative 1. So that tells me one thing. That tells me that I'm going to reflect over the x-axis. So what's going to happen is this. In order to reflect over the x-axis, I'm either going to bounce above or below it depending on where I am. So when you bounce over the x-axis, what happens here is your x values stay the same. It's your y values that become opposite. So what that means is negative 2, 2, negative 1 ends up here. Because as you cross through the x-axis, you end up same distance away, just in an opposite spot. 2, 3 ends up at 2, negative 3, and then 4, 1 ends up at 4, negative 1. So that would be my reflection over the x-axis. Okay, so I just changed where it's facing. And then the last step would be to go down 2 units. So from my reflection, I go down 2 units, down 2 units, and down 2 units. So this will be my final spot, and this is my graph of k of x right there. Okay, g of x would be in the blue after the reflection, like that. Okay, last page. First thing I'm going to do, this is a c value being negative 1, so the only thing that happens here is this is a reflection over the y-axis. So when you reflect over the y-axis, you're either going left or right depending on what side you're starting on. Okay, so when I reflect over the y-axis, the y values stay the same, the x's are now opposite. So instead of being at negative 2, negative 1, I'm at positive 2, negative 1. Instead of being at 2, 3, I'm at negative 2, 3. And 4, 1 is at negative 4, 1. So this is my reflection over the x-axis. So this is my g of x right here. And this next one, my c value is now negative 2. The negative sign is the reflection. The 2 value, now again, this is a horizontal dilation by factor of 1 over c. So the reciprocal of 2 would be 1/2. So what that means is all of my x values, horizontal is x values, all of my x values are going to multiply by 1/2. So half of negative 4 is negative 2. Half of negative 2 is negative 1. Half of positive 2 is positive 1. So this is my horizontal dilation by a factor of 1/2. So what you'll notice is I'm getting pulled closer to the y-axis. Okay, so I'm compressing myself, so I'm starting to squish in and get closer and pulled in. Okay, also notice that the y-intercept stayed the same in this case when I reflected over the y-axis and a horizontal dilation. that's supposed to happen as well. Okay, so this next one, compare the two graphs, f of x and g of x. Write the equation for g of x using transformations of f of x. F of x is my solid line, g of x is the dotted line. Okay, so what I notice here is for my solid line and my dotted line, I go up one and right one, up one and right one. So it did not change the shape of the V. So there is no dilation here. That means that the only thing that's happening here is translations, up, down, left, right. So my vertex is 0, 0. How do I get it to 2, 4? So I have to go 2 units to the right, and then I have to go 4 units up. So I have to go right 2, and I have to go up 4. So therefore, I can count on that. So if I want to go right 2 units, that becomes x minus 2, f of x minus 2. And if I want to go up 4 units, it will be plus 4. That means that my h value was 2 and my k value was 4. And that's how I would get my answer here. Okay, for my second one, my V shape, first it has to turn upside down. So upside down. How do I get it to do that? Well, in order to turn it upside down, that means I have to reflect over the x-axis. In addition to that, what you'll notice is I have a point that was at 2, 2, and now it ends up at 4, 2, because instead of going up 1 and right 1, I go down 1 and right 2. So it's changed. The steepness has changed. Okay, so if I return myself upside down, reflect over the x-axis, that means that your a has to be less than 0. In addition to that, it's going to have to go up 3 units. So that means k is 3. So once I go up 3 units, I'm going to be kind of looking like that. And then now I need to change the steepness. I need to go and from 2, 2, and I have to get to 4, 2. Okay? So in order to get to 4, 2, I have to be twice as long. Okay? So what's going to happen there, let's see here. I am here. I need to get there. Okay, so in order to do that, this is going to be a horizontal dilation. Okay, and so what I need to do now is I need to get to 4, 2. So therefore, my dilation is by a factor of 1 over c, so the reciprocal. So in this case, it needs to flatten out. So that means my c value, in order to get there, I am going to do a multiplication by 4. Okay, because if I reflect and then I go up, in order to get from 1, 2 now to get to 4, 2, c is going to have to be 1/4 because the reciprocal of c is going to be 4. So dilation by factor of 4. Okay, so in that case, once I have the ordered pair 1, 2, and I multiply the x by 4, 1 times 4 will take me to 4, 2. So what that means now is this. I have a negative f of 1/4 x and then plus 3. I account for the reflection to turn upside down. I account for the graph going up 3 units. And now I account for the reciprocal. So the reciprocal of 1/4 is 4. That's my horizontal dilation because I had to multiply the x value by 4. So this will get me to where I need to be. Okay. In addition to that, last page, table of values. Okay, given the numeric representation, create a table for g of x. So g of x, what I have here, my h value is 8 and my k value is 13. So that means that I need to go right 8 units and I need to go up 13 units. So if I have to go right 8 units, I'm just going to add 8. If I have to go up 13, I'm going to add 13. So that means negative 3 plus 8 is how I get 5, and 3 plus 13 is how I get 16. So all I was doing was I was using the previous, so I'm going to use 0 and 0, so 0 plus 8 is 8, and 0 plus 13 is 13. I have a 2 and a negative 2, so 2 plus 8 is 10, negative 2 plus 13 is 11. And then 5 plus 8 is 13, and negative 5 plus 13 is 8. So these are the new ordered pairs after the transformations happen. Okay, for number 2, my A value is negative 1/2, my H value is negative 4, my K value is negative 6. So this is vertical, this is horizontal, this is vertical. So therefore, the horizontal, if I want to go left 4 units, it's just x minus 4. That accounts for that. The dilation will multiply, the shift will just add or subtract. So it's going to look something like that. Okay, so here's negative 8 minus 4, that's negative 12. I got negative half times 10, which is negative 5, and negative 5 minus 6 is negative 11. Okay, negative 4 minus 4 is negative 8. Negative half times negative 6 is positive 3, and 3 minus 6 is negative 3. 0 minus 4 is negative 4. Negative half times 6 is negative 3. Negative 3 minus 6 is negative 9. And then the last one, 3 minus 4 is negative 1. And negative half times 0 is 0. 0 minus 6 is negative 6. Okay. For this last one, my A value is 4. My C value is 1/5. My K value is 2. This is vertical, this is horizontal, this is vertical. So vertical, I have 4y plus 2. For my horizontal, keep in mind that my dilation is by a factor of 1 over c, the reciprocal. So that means that my dilation means that I am going to multiply by 5. So therefore, because I am multiplying by 5, that would be 5x. Okay, so negative 1 times 5 is negative 5. 7 times 4 is 28, and 28 plus 2 is 30. 0 times 5 is 0. 1 times 5 is 5. 2 times 5 is 10. Notice that this is just still going to be 30 and 30 and 30. Negative 1,7 is up here, 0,7. This is just a horizontal line. Okay, and so this is where it's going to take you as well. Okay, we're not going to be doing odd and even functions, so this is it for transformations. So hopefully you have a better understanding of what direction to go, what you're multiplying and adding by as well, so that way you can do your transformations.